Hey everyone, welcome to my Intro to Physics, episode number 6. Today is going to be a small introduction into using some calculus in a physics problem. Let's jump into reading the question. A rod extends from x equals 0 meters to x equals 123 millimeters and has uniform cross-sectional area A equals 10.0 centimeters squared. Its density increases between its end from 3.70 grams divided by centimeters cubed to 24.90 grams divided by centimeters cubed. Part A, identify the constant B and C required in expression rho equals B plus C times x to describe the variable density. Part B, the mass of the rod is given by m equals the integral of rho times the derivative of volume, or equals the integral of rho times the area times the derivative of x. And more specifically equaling an integral from r0 to rx value of b plus c times x times r area times the derivative of x. And carry out the integration to find the mass of the rod. This equation looks quite complicated, but it seems to come from the density formula, which is rho equals mass over volume. And rearranging that, we can get mass equals rho times volume, and this is what is used in the first part of the integration. To solve the integration, though, we need to solve for b and c first to eventually plug in. So let's solve for part A first, and move on to the given variables. The initial x value is given at 0 meters, and the final x value is given at 123 millimeters, or 12.3 centimeters, as the other variables deal with centimeters. And the area is given at 10.0 centimeters squared. The initial density, or rho, is 3.70 grams over centimeters cubed. And the final density is 24.90 grams over centimeters cubed. Write the given equation for density, which is rho equals b plus c times x. We are looking to solve for b and to solve for c. To solve the values, we should plug in what we have, so now it's time to calculate. Rewriting the equation, we get rho equals b plus c times x. Since we have some initial and final values, let's go ahead and start plugging in for the initial density and the initial x value. So let's mark this one as rho initial and x initial. After plugging, the equation is 3.70 grams over centimeters cubed equals b plus c times 0. Then we get 3.70 grams over centimeters cubed equals b plus 0. This gives us the b value, which just equals 3.70 grams over centimeters cubed. Let's write that in for b. Now that we have b, let's solve for the final values that we were given. We'll have rho final equals the b 3.70 grams over centimeters cubed plus c times x final. Plugging in the final values, we'll get 24.90 grams over centimeters cubed equals 3.70 grams over centimeters cubed plus c times 12.3 centimeters. Subtract 3.70 grams over centimeters cubed from both sides and cancel on the right side. This leaves us with 21.2 grams over centimeters cubed equals 12.3 centimeters times c. Now let's divide both sides by 12.3 centimeters and cancel on the right side. This leaves us with a final answer of c equals 1.72357 grams over centimeters to the fourth power. Remembering we would multiply the bottom centimeters cubed by one more centimeter to get the power of 4. Fill in our answer for c now. With both c and c solved for, we can now carry out the integration for part b. Part b gives us the mass of the rod by this integral equation. With everything we needed, it's now time to calculate this integral. Writing the integral with our constants of x and area, we get the integral from 0 to 12.3 centimeters of b plus c times x times the area of 10 centimeters squared times the derivative of x. With a constant area of 10 centimeters squared, let's pull that out front of the integral. So we get 10 centimeters squared times the integral of b plus c times x times the derivative of x. Carrying out the integral now, the derivative of x is gone, b goes to b times x, and c times x goes to c times x squared divided by 2. The equation is 10 centimeters squared times all of b times x plus c times x squared divided by 2 from 0 to 12.3 centimeters. With the integration done, the mass can now be solved for by plugging in b and c. The final equation to solve is 10 centimeters squared times all of 3.70 grams over centimeters cubed times 12.3 centimeters plus 1/2 times 1.72 grams over centimeters to the fourth times 12.3 centimeters squared, all minus 10 centimeters squared times all of 3.70 grams over centimeters cubed times 0 plus 1/2 times 1.72 grams over centimeters to the fourth times 0 squared. Looking at this minus half on the right, all these terms will multiply by 0 and thus go to 0, leaving us a minus 0. Now multiplying the left side, we get 10 centimeters squared times all of 45.51 grams over centimeters squared plus 130.1094 grams over centimeters squared. Remember, our units got multiplied too, lowering the power to centimeters squared. And then we are finally left with 10 centimeters squared times 175.6194 grams over centimeters squared. Canceling the centimeters squared now, we can multiply out to get our final mass to equal 1,756.194 grams. So after solving for b and c, we were then able to integrate for the mass and plug in b and c variables to find our final mass of the object to be 1,756.194 grams. I hope these intro problems are as helpful for you as they are for me. Thanks so much for watching. Hope you come back to learn more exciting material, and see you next time.